Okay, so we entered all of this in list 1 in the calculator, all of this in still list 1, list 2, list 2. They have to line up. It's not one of those things where it's okay if they're not in the right order. I've put my data into the calculator. Okay, are we ready? Everybody have their data in the calculator? Okay. All right, you're going to go to the stat, and it gives you the edit and the calculate and the test menu. You're going to go over to calculate. And we have one variable statistics. So we're going to hit enter on number 1. And our data is in list 1 and list 2. That's where I put mine. List 1 is my values, list 2 is my frequency. So how do I get this to be list 1? I hit second, and then above the 1 is list 1. Then I hit enter, and then I do second again, and then I do above the 2 is list 2. That's my quick way of grabbing my lists, and then I'm going to hit calculate. So this helps us with part B. Part B asks for the mean and the standard deviation. I wouldn't have expected you to do this standard deviation by hand anyways. So the mean is 67.12, and the standard deviation, we're going to use S for standard deviation, 3.79. Now if you keep scrolling, hit the down arrow, we have our 5-number summary here. Our minimum, our Q1, our median, our Q3, and our maximum. Okay. So it asks for the median in the IQR. The IQR is Q3 minus Q1, which equals 5. Okay. Beautiful calculator, does all the hard work for us. Okay. Well, not that. Now it asks for a histogram, so I can go into the stat plot menu, stat plot, hit enter, and go over to the histogram. Make sure you hit enter on it. And again, my data is in list 1 and my frequency is in list 2. You don't always have a frequency list. Sometimes that frequency will be blank here, or it will be 1. Okay, I think in one of our stats it says frequency list, so it's blank. And in stat plot it says frequency, you have to put 1. If you were to go through and put 60 twice, and then you entered 61 6 times, so you put all 130 values in one list, then your frequency would just be 1. And then we zoom 9 to make a histogram. And remember that you can hit trace. It tells you what the values are. And this is a pretty good one, actually. You can use the calculator generated one because the values make sense. The first bar is from 60 to 62. There's 8 people in it. The second bar is from 62 to 64. There's 16. And then you can copy that onto your paper. Okay. Any questions? So when it says write a few sentences describing the distribution, once we have our histogram, you would draw it and label it like this. Yes. Just back table there. And 78. Go ahead and sit in an empty seat somewhere so that you're not next to Amelia. Okay, so we're labeling that. This is 8, right? That was, I think it said 16. Yeah, 16, 25. Obviously, you're not putting a picture of your calculator on your homework, so I'm cheating. But that's what you're going to make sure your axis looks like. Okay, and then you can just count up to 25 and make your bars. So how would you describe this distribution? What is this shape? Unimodal and skewed right. Right is towards large numbers. The median is, what did we say, 66. The IQR is 5. And there's possible outliers. We're going to talk today about the outlier rules and calculating exactly whether we have outliers or not. Okay, so there we have our few sentences. It's actually just one, right? What am I missing? I should probably have some context, right? So 66 inches, the distribution of height is, there's my context, right? Remember in AP questions, if we don't have context, we're going to get points marked off. So the minute we just say, this is the distribution of height, and this is what it is. Okay, we use the fact that it's 66 inches, IQR is 5 inches, right? That's how spread out the middle 50% is, and we'll talk a little bit more about whether there's outliers and how to determine that. One of the things we didn't quite get to yesterday was which measure of center to choose when I'm describing. Because if we looked at the calculator, our mean was 67.11, and our standard deviation was 3.78. So SX and X bar. Because the data is skewed, mean and standard deviation are not resistant to outliers and skew. So when the data is skewed, the mean tends to be higher. If the data is skewed to the right, the mean tends to be higher than the median. If the data is skewed to the left, the mean moves with the skew. The mean tends to be lower than the median. The median's kind of just smack there in the middle, and it doesn't really matter what the skew is. So when the data is skewed, we want to use the median and the IQR. And when the data is symmetric, we want to use the mean and the standard deviation. Okay? So for symmetric, that's the only time for center and spread, we talk about mean and standard deviation. When it's skewed, we like median and IQR because those are both resistant to outliers and skew. Okay. Anything else from the homework? No? Okay. So let's talk about the outlier rules. Now this is not the next slide. This is actually in the next chapter, the beginning of the next chapter, because I forgot that our new book moves this from chapter 4 into chapter 3. But it makes sense. We just talked yesterday about the 5-number summary and describing, finding the mean and the IQR. So now let's talk about how to determine if there are outliers. So you're flipping back to the chapter 4 PowerPoint. It should be the first slide, I'm hoping. Yeah? It may look a little weird because I think when I imported it, some of the titles went missing. Or did I move it? So this one says on the top, creating box plots. We made them yesterday without outliers. Normally we like to show outliers on our box plots as well. So when we are determining whether or not there's outliers, we need to have the 5-number summary and we need to have the IQR. Okay, so we're going to just go use our data from yesterday. Okay, what did we do? We did the chip example, right? We had, let me pause. Yesterday we looked at the percentage of air in bags of chips. We think there was outliers, right? Based on our box plot, we think this 19 is outlier, right? It's pretty low compared to the rest of them. And how do we know for sure? Well, we have outlier rules that help us create fences. Okay, think of a fence around a property and a dog outside. That dog is lying outside, outlier of that fence, right? So he's on the outside looking in. Data values that are outside the fences are considered outliers. So this is the standard. Anything within is not considered an outlier. Everything larger than the big one, lower than the low one is an outlier. Our outlier rule is for my lower fence, and you have this written down up there, Q1 minus 1.5 times the IQR. And for the upper fence, it's Q3 plus 1.5 times the IQR. So, can we do that calculation? I think we can. Your IQR is 10. Your Q1 is 39. Your Q3 is 49. Take a second and calculate that upper and lower fence with this data. So our calculation for the lower fence should look like 39 minus 1.5 times 10, right? Which is 39 minus 15, 24. So my lower fence is 24. Any data values below 24 are outliers. Do we have a lower outlier? Yes, 19 is less than 24, so it's an outlier. Then you calculate the upper fence, 49 plus 1.5 times 10, 49 plus 15 is 64, right? So the maximum of 59 is lower than the fence, so there are no upper outliers. Okay. So it's like there's imaginary fences here at 24 and 64. Anything outside those imaginary fences is an outlier. So we can see that the 19 falls outside that. Okay, the maximum is within the fence, therefore the maximum is not an outlier. Okay, how does that change my box plot if I want to show the outlier on my box plot? So I'm going to draw the box plot below it with an outlier. So because the minimum of 19 is an outlier, I'm going to put a dot for it. Let me do it in blue. We put a dot at 19. And my minimum, this part of the graph, gets pulled into the next data value. What's the next data value? 28. I do not put the fence on my box plot. The fence is not a data value. The fence is imaginary. That's why you can barely see it in the green, right? I don't put that on my graph. I go 19 is an outlier, so my next minimum would be the 28. So my graph gets pulled into 28, and that becomes the minimum line. And the rest of the graph looks the same. So this shows 19 as the outlier. Okay, this becomes 28, the next data value. That's not an outlier. So if you had another data value that was 20, that's still an outlier. So I would have another point there as an outlier. Questions? So whenever you're asked, are there outliers now, if you have the data, you're expected to use the outlier rules to calculate the fences and then mathematically determine whether they're outliers. It's not a judgment call anymore if you have the data. If you're looking at a histogram and you don't know the data, then it's a judgment call. Yes, it looks like there's possible outliers. If you have the data, it has to be calculated. Okay, so that will be on our chapter 3 quiz. Calculating the outliers, determining which points are outliers. Okay. Figure out some of these things. Okay, I don't want to talk. So we looked at standard deviation in the calculator. The calculator does it for us. We're almost never going to do standard deviation by hand. Statisticians don't do calculations by hand. They plug all their data into the calculator, not the calculator, a computer, and the computer does all the work for them. What we really need to be able to do is interpret what the computer gives us. So we have two calculations of spread. The first is called the variance. It's the sum of the squared deviations from the mean. You calculate how far each data value is from the mean. You square it, because if I take those numbers, the deviations from the mean, and add them up, I get 0. The mean's the middle. There's an equal distance above it and below it. So that doesn't help us to just find the deviations and add them up. We got to square them to make them positive. Absolute value could make them positive, but absolute value you can't undo the way you can undo squaring something. So the square and square root become important features, functions for us. So we have this calculation. What you do, the deviations, okay, so the deviations are how far each point is from the mean. So y1 is the data value minus y bar, the mean. So the data value minus the mean. Like I said, when you add those all up, you get 0, so that doesn't tell us anything about how spread out the data is, so we have to square it. And we basically find the average of those deviations. But then we have to unsquare it so that the number makes sense with our data. So we square it, then we do the y1 minus y bar squared. Then we find the sum and divide by n minus 1. Okay, we realize that there's variation in our data, and so when we do the average variation, we account for that by subtracting 1 from the total number of data values. Okay, so we're going to do an example in a minute. Standard deviation is after I add that all up, divide by n minus 1, I take the square root. So the standard deviation is the square root of the variance. We have two symbols for square root in the calculator, Sx and sigma x. Lowercase sigma. It's like a circle with a hat on it. It's like an O with the hat on. Okay. In the calculator, Sx uses n minus 1, and sigma uses n. We're going to always use Sx. In the calculator. Okay. Okay, so here we have a bunch of data, and we're going to calculate the standard deviations. Okay. So, can you find the mean of each group? We need the mean of each group in order to find the standard deviation. Any idea what the mean might be if they're all 10? 10. And the standard deviation is 0. There is no variance. They are not varying or deviating from the mean. They are all the mean. So that's the idea of a standard deviation of 0, means all the data values are the same. Group 2, what's the mean? It's 10. What about group 3? Any guesses for 4? And 5? And 6? All of these groups have the same mean, but they're not all the same. So we need another statistic to help us describe what we're seeing. Mean isn't always the only measure that's going to help you decipher or tell the difference between several groups. How spread out they are, standard deviation, is another measure for that. So we are going to, we'll do our little y1 minus y bar. Okay, we're going to make a little table. And then we'll do y1 minus, it's actually little I, y bar squared. Okay, that's what we need to find. So my first one, we already know the group 1 is 0. But group 2, the yi is 8 minus 10. So that's negative 2. Negative 2 squared is positive 4. Agree? The next point is 10. 10 minus 10 equals 0. 0 squared is 0. 10 minus 10 is 0. And then the last one is 12 minus 10 is 2. 2 squared is 4. Then we find the sum. Everybody with me so far? We're taking each of these values, subtracting them from 10, which is our mean, and then squaring that value. At this point, these should all be positive. Even if you plug a negative into the calculator and square it, we know a negative squared is positive. If you don't put it in parentheses in the calculator, it's not going to square the negative. You have to be smarter than your calculator and know when things should be positive because you're not putting it in right. What's my sum? 8. What's my n? There's 5 values. So 8 divided by 5 minus 1. 8 divided by 4 is 2. And then the standard deviation is the square root of 2, 1.41. 5 values. So we divide by n minus 1. so the standard deviation for group 2 is 1.41. Can you find the standard deviation for group 3, 4, 5, and 6? You're finding the average difference from the mean. So you're going to do it again. Do you have to use the table? No. Okay. But I think it helps organize it all. Yes, Emma. Yi is each individual data value. So like y1 is 8, y2 is 10, y3 is 10, y4 is 10, y5 is 12. So it's just the individual points, the individual data, minus the mean.
So that was just the sum of, or the standard deviation of that row.
Of group 2, yes. All right, so take some time right now and calculate some of the other standard deviations. Do we have an answer for group 3? 7.07. What about group 4? Group 5? 05? 06. And do we have group 6? 3? Okay. So, does it surprise you that group 5 has the largest standard deviation? No, because it has more values that are farther from the mean, right? The 18 and 20, a 2 and a 0, that should be more spread out than the others. So, to interpret standard deviation, let's talk about our singers in the choir, because I have that standard deviation up. The singers in the choir had an average height of 67.12. Now, X bar and Y bar, both okay to use for mean. Your calculator uses X bar. Your book likes to use Y bar. I don't know. SX is equal to, what did I just say, 3.78? 3.79, okay? We're talking about height, so this is inches, right? So we say the typical deviation from the mean is 3.79 inches for this choir. So it's the typical distance every person's height is from the mean. We can pretty much say it that way the same every time. The typical deviation from the mean is blank, and what are you talking about, right? The standard deviation, and then add your context. Okay. You could also say, on average, the choir members' heights differ from the mean by about 3.78 inches. Okay. So another way to write it would be, on average, the choir members' heights differ from the mean I can't spell, by about 3.79 inches. Okay. Either one's an okay way to interpret and understand what standard deviation means. Okay. Okay, so the last thing is, again, choosing which measures of center and spread are appropriate. It's important to look at the data, the distribution, which is the graph. The symmetrical data, we'll use mean and standard deviation for, and we have a whole chapter about mean and standard deviation in chapter 5, using the normal model. and skewed data, we are going to use the median and the interquartile range. We do not use mean and IQR together, and we don't use median and standard deviation. The mean is required for the calculation of standard deviation, therefore they go together. The median is required to find the quartiles, which is required to find the IQR, therefore they go together. Now another thing we need to know is that the mean moves with the skew or outliers. If it's skewed right, the mean moves to the right. It's higher than the median. If it's skewed left, the mean moves this way, and it's lower than the median. The median and the IQR together are resistant to the skew and outliers. So they'll pretty much stay the same. The median might move a little bit if you add an extra data point, but it doesn't matter what that value is. You could add a height of 100 inches into your data and it's not going to change the median of our data because it'll move from the 65th to the 66th person, and that was still 66 inches in the example we looked at. But if you add that into the mean calculation, your mean is going to be much higher than it was before, right? And if you add in a height of 40 inches, now your mean is going to be smaller than it was before. So your mean moves with the data, okay, with outliers and skew. Okay. Let's take a second and look at the cumulative density plots, these ogives, and how to read them. Okay, that was one of the things that stood out when you did your discussion. This graph is weird. One, how the heck do we make it? We don't. We let computers make it for us. But the second is, how do we answer questions about it? Okay, so the first question here, well, we have how fast do horses run? Kentucky Derby winners run well over 30 miles per hour, as shown in the cumulative frequency plot. Note that few have one running less than 33 miles per hour, but about 86% of the winning horses have run less than 37 miles per hour. So it says estimate the median winning speed. The median is the middle, right? What percent of the data is the middle? 50%, right? So on the side here, we're looking for where's 50%? Right here between 60 and 40, right? So when I'm reading this ogive, I can draw a line over to the line here, and then I can drop it down, and it looks like this is 50%, which is the median. It looks like the median is about 36 miles per hour. See that? Okay. Then it says estimate the quartiles. Well, quartile 1 is what percent of the data? 25. So if this is 30, then 25 is about here. And I'll just draw it over and drop it down. Looks like Q1 is about 35, maybe 34.9, just estimating. Q3 is 75% of the data. So that's Q3. 25% is Q1. Draw my line over, drop it down. Would say that's about 36.8, 36.7. There's no way to know for sure. Then could you find your IQR? 36 minus 35, 36.8 minus 35, approximately 1.8. Okay, so that's how we read the and answer questions about our ogives. Okay, then if you were asked to create a box plot, you just need the maximum, which is 38, and the minimum, which is about 31.4. And then you can draw your box plot with your 5-number summary. Okay, the range would be that 38 minus 31.4. Okay, and then you can't really talk. Well, you can. Once you've drawn your box plot, you can see the shape. How it, if it's skewed to the right, is skewed to the left. The whiskers, you're looking at how far away that half is from the mean. The median is one side longer than the other. Okay, so does that help kind of clear up how to look at those graphs and what they mean? Like I said, you're never going to have to make one. Okay, but you will be maybe asked to find the IQR from it. So you find your 25% and your 75%, and then you subtract those numbers. Okay.